Chapter 2.
So the first formula we have is the distance formula. It's the final distance equals the original distance, the starting point, plus velocity, original, times the time, plus 1/2 times the acceleration times the time squared. The second formula we have is to find the final velocity. So that you just take the original velocity and add it to the acceleration times the time. The third we have is the velocity squared, which is equal to the original velocity squared plus 2 times the acceleration times the change in distance, which is x final minus x original. Next we have average velocity, which is the change in distance from x to the x original over the change in time. And the last one we have is the average acceleration, which is the change in velocity over the change in time.
So another thing we learned in this chapter is velocity. And velocity is measured in meters per second, or kilometers per hour, or whatever. And we also learned about acceleration. Acceleration is explained through meters per second squared, or kilometers per second squared. But basically, how we calculate velocity, like we explained earlier, is we do the original velocity plus acceleration time. And since acceleration is meters per second squared, and time is measured in seconds, one of the seconds cancels out, so you're left with meters per second. And then
Okay, so now we have the acceleration formula, which you can find using the velocity squared formula. So VF equals VO plus AT. So what you do with this is you change that to VF minus VO over T equals acceleration. Now acceleration is measured in either meters per second squared or normally kilometers per hour squared, but if you're going really fast, kilometers per second squared. But what this does is it'll take it and you'll be subtracting your meter per second times and then putting them over a time in seconds. And then that's going to find that it comes down to be 1 meters per second value, which is the whatever this equals, over seconds, which turns out to be meters per second squared, which is your final unit.
another thing we learned about was constant acceleration. An example of constant acceleration is gravity, which is negative 9.8 meters per second squared. Now, acceleration can be constant, but it can also change. Like, so say a car is moving at 30 meters per second, but say it starts to slow down at a negative 3 meters per second squared at first, and then changes to negative 2 meters per second squared, then finally becomes 0 meters per second squared. Now we can also have constant velocity. Now, constant velocity is basically when an object has stopped moving, so like 0 meters per second. Okay, so constant velocity is when an object is moving at the same speed without acceleration, so 0 meters per second squared is the acceleration equals the velocity. An example of this is a car moving at 15 meters per second, and it just continually keeps going.